Hello student to our web optics course. Today we have lecture number 34 and in this lecture we will going to continue with the single slit diffraction problem. So, in the single slit diffraction problem, we already derived that we have a single slit pattern. This is a single slit aperture, and when the light is falling here under Fraunhofer diffraction category, we have a diffraction pattern which is like this. It is essentially a sinc function. So, the intensity is a function of theta will be I naught sine square beta whole divided by beta square. That was the intensity distribution we find. What is beta? Beta is pi d divided by lambda and sine theta. Theta is the angular separation along this direction, and d is the slit width. This is d, and lambda is the wavelength that is applied here. So, this is overall the structure that we calculate, and then we try to understand what is the condition of maxima and minima. That means, at which theta I am going to get maxima and minima. So, let me write down the structure once again. Several times I am drawing this structure. So, hope you realize that how these things are happening here. So, this is a symmetric structure, sinc function, and along this direction we have a beta which is pi multiplied by d divided by lambda sine theta, and this is intensity as a function of theta that I plot. This is the maximum intensity which is I naught, and if I move along this direction, I find the intensity is rapidly falling, and here it goes to 0 in principle, then again move up and then goes to 0, again move up, goes to 0 like this. And this 0 point is the minima, and the condition of the minima we figure out last day. Minima when beta is equal to n pi, where n is 1, 2, 3 and so on. This is minima, and from that condition one can calculate that when n pi is equal to pi of d divided by lambda, and this is the nth 0. So, I have sine theta n. So, one can calculate what is sine theta n. So, pi will going to cancel out. So, we have n lambda divided by d is equal to sine theta n. So, from this value one can calculate this is the angle at which we have the minima. If we increase the value of n, we can go first, second, third minima and so on. Now, we are going to extend this calculation for maxima. So, what I am trying to get is, this is the structure. This is the central or principal maxima, and this is the secondary maxima. This is the first secondary maxima, and we want to find out what is the location of the beta for that value. So, my aim is to find out what is the value of beta for this, or what is the value of beta for this, and so on. So, it is not straightforward, because here I have I, which is a function of theta or beta, is I naught sine square of beta divided by beta square, where beta is pi d divided by lambda and sine theta. That was the thing we have. So, for maxima, what we have, that this intensity, which is a function of beta with respect to beta, if I make a derivative, that is essentially 0. That is the condition for the maxima, that the intensity of the intensity which is a function of beta, the derivative with respect to beta should be 0. So, that means I have I naught d beta and sine square beta divided by beta square, that is 0. That is the condition for minima. And now, if I expand this condition, it is 2 of sine beta, then cos beta, then beta square, minus 2 of beta sine square beta whole divided by beta to the power 4, that is essentially 0. So, from that it is easy to show that I can have an expression beta cos of beta is equal to sine of beta. This is the condition we have, and that condition simply leads to beta is equal to tan beta. So, this is the condition of, if I manage to solve this equation, then this equation gives me the value of beta for which this structure have a maxima. So, obviously 0 is a solution. You can see if you put beta equal to 0 left hand side and in the right hand side, they are the solution, and the 0 solution is a solution for principal maxima, which is this point. So, here we have a trivial kind of solution beta equal to 0, but I am interested to find out the solution here for this point, and so on. So, that means not only one solution, we have many other solutions. So, beta here several time I am writing this is pi d divided by lambda, then sine theta. That is the value of the beta. Well, in order to solve this, so this equation cannot be solved analytically. So, we need to use the graphical method of that, and that means I need to plot tan beta and beta together, and their cutting point will be the solution we are looking for. So, this is the plot. So we have, so this is, say this point is pi by 2, and then this is pi, and then this is 3 pi by 2, and then this is 2 pi, and so on. So we know that the tan how the tan curve behaves. So the tan 0 is 0, and when it is pi by 2 it reaches to infinity. So I have a curve something like this, and then again at minus pi by 2 it goes to 0, and then it come back and come here, and again it goes like this. So this is the way the tan curve will go. And now I need to draw the beta curve also. So this is the green line, is basically these are tan beta curve. Y equal to tan beta curve I am drawing essentially. So I draw here beta, the y axis, this y equal to beta, and y equal to tan beta, both I am drawing. And here in this axis I draw x equal to beta. So beta is a function, so x y I am plotting as a function of beta. So this is tan beta. Now I draw the y equal to, say, beta I draw, which is a 45-degree line roughly. So you can see that it cuts to a point. So first point is 0, and second it cuts at some point. So and also it cuts to another point, and so on. Okay. So the solution, the first solution of beta is equal to roughly around 1.43 pi. This is the point when once if you do this calculation using computer, then that should be the first solution. The second solution will be when beta equal to 2.46 pi. The third solution when beta equal to 3.47 pi, and so on. So these are first three solutions. So this first three solution means if I draw the structure, draw the diffraction pattern, and if this is my beta, So, this point is my beta 1 first solution, and it is 1.43 pi. This is my second, and the value of beta, which is 2.46 pi. This is my third one, and this value is beta equal to 3.47 pi, and so on. So, this is the points where the values of beta I calculate. So, now I need to calculate also what should be the amount of intensity. Here we know that is the intensity, and that intensity is I naught, and the intensity as a function of beta is known, which is I naught sin square beta divided by beta square. Now, once we know the value of the beta as a maxima, so when beta tends to 0, that is this point, then I theta I as a function of beta is simply I 0, that is the maximum intensity. So, now I want to find out the first so I max. So, the first secondary maxima, what is the intensity of that? So, I of the first secondary maxima, if I write first, so that is the value of I at beta equal to that point 1.43 pi. So, whatever the value you have on the right hand side, if you put this value, then so essentially this is I naught, I have sin square beta divided by beta square that is calculated at the value beta equal to 1.43 pi. So, this is the value where this is the amount of intensity of the first maximum, the first secondary maximum. So, this value if I now want to find out what should be the ratio. So, I first divided by I naught, that is the ratio between these intensity and this intensity, just to find out that how small the first minima compared to the principal maxima intensity wise. So, that ratio is essentially beta square divided by sin square of beta at the point beta equal to 1.43 pi. And if I calculate, if somebody calculate this amount, it will be nearly equal to 221.2, that should be the value. So, that means no, this is not actually this value, yeah. So, no, this is actually point, no, this value I am okay, let me erase this. So, actually if so beta square, okay, I need to calculate that what is the value of the beta, because I need to calculate sine, and then so this value is okay. Let me write it. I want the student to calculate these things. So, beta square means it will be 1 point something like 1.43 and pi whole square of that and divided by why it is whole divided by sine of, okay, it is not erasing properly. Yeah, here we have. So, whole divided by sine square, and that value actually we need to calculate 1.43 pi square of that. So, I get a value here, and that value basically tells us that what should be okay here. Okay, so no, this yeah, I first, okay, so here I make a mistake. So that thing, so that is why it creates some problem. This is I naught and this is this is I first. So, whatever the value you get here after calculating, you will see that that value will be the ratio of I 0 divided by I first, and you will find that this value should be order of, as I mentioned, it should be order of 20. So, that means there will be a 20, there will be a, so the maxima, the principal maxima is nothing but the 20%, roughly the 20% of the central maxima. So, the first principal maxima is roughly about the 20%. If you calculate and find it this value, you will find it is roughly the 20% of the minima. In the similar way, you can also calculate what is the secondary maxima, and then secondary maxima, the second secondary maxima and the third secondary maxima, and so on. And you will find that there is a very rapid decrement of the intensity if you go more and more order of this maxima. The first maxima will reduce heavily, that is like this. So, if it is 1, if it is 100, then this value is merely 20, and then you will find it will be much less, and so on. So, if I have this is I 0, so this value is roughly 20% of the maxima I 0, and the rest of the value is even smaller. Next, one thing I need to calculate, and that is the width of this principal maxima. So, width, this is the point from here to here is called the half width. This is half width. So, what we calculate is the beam width, whatever the beam we have, that we calculate. So, I, which is a function of beta, is distributed in this way. Along this direction we have beta. So, I is I naught sine beta divided by beta and whole square of that, that is n. And the first minima that is when beta equal to pi. So, at this point beta is equal to pi. At this point we have beta is equal to pi. So, that means we have pi equal to pi d divided by lambda and sin theta first minima, and I write theta 1. So, theta 1 is the angular separation from this point to this point. So, that gives me simply sin theta 1 is equal to lambda divided by d. Okay. So, what I am calculating, this is the structure, let me draw it. This is the principal maxima, and then we have secondary maxima, and from this point here to here, this angle is my theta 1. This angle is my theta 1. So, if we have this length as L, and from here to here, from this central point to this point, if this is my say W, say W 1 for first. So, then I have sin theta for small theta, sin theta 1 is nearly equal to W 1 divided by W 1 W 1 divided by L, and that value is nearly equal to theta 1, or this is lambda divided by d. So, my angular separation delta theta will be 2 of theta 1, and it should be 2 of lambda d, that is the angular width. And if I want to find out what is the spatial width, so that is 2 of W 1, that is double of the half width, and that is simply 2 of lambda of multiplied by L divided by d. So, that is the width, that is the width of I need to write not erasing, but anyway. So, this amount is so that is my delta lambda angular width, sorry, delta theta angular width, and that is equal to, if from this point it is L from here to here, and here to here if it is W, then delta theta equal to 2 of theta 1, and that is 2 of W divided by L, and width is the width of the central maxima will be simply W P, that is 2 of W will be 2 of lambda of L divided by D. So, obviously, it depends on L. So, the point is, if I move the screen, so this is my source, double slit source, and initially I have a screen here, and I have okay, I need to erase this. So, I have this so, I have a source here, and this is the structure we have for one length, and for another length I have the structure like this. So, the width of the central maxima will going to increase over the distance. So, this is my theta 1. If this is my distance, the first L 1, and if this is the distance L 2. So, the width here W 1, the width here W 1 so, width here W 1 will be 2 lambda divided by D, which is constant, multiplied by L 1, and here W 2 will be 2 lambda D multiplied by L 2. So, these are the two widths one can have, and this width depends on how far the screen is placed compared to the source. So, today I do not have much time to discuss about more regarding slit. Mostly this is the expression we had, this is the calculation we have for a single slit diffraction. In the coming class, we will extend this idea and calculate how the intensity distribution will going to change if I introduce another slit, that is, instead of having single slit, if we have a double slit, then what should be the distribution of the intensity, and then calculate all the things, fringe width, etc. for that case. So, with that note, I would like to conclude here. Thank you very much, and see you in the next class.